Assalamu alaikum students. Myself Zain Javed Mughal, your chemistry teacher. So in the previous lectures in the class, we have gone through the chapter number 3. The topic that we have covered up till now are what are organic compounds, what are their general characteristics, how the organic compounds can be represented, and what are the uses and sources of organic compounds. And beside this, we also have gone through the IUPAC nomenclature of alkane, alkenes, and alkynes. That what are the rules to name the alkenes that are existing in this world, and what are the particular or specific rules to name the alkenes and alkynes given by the International Union of Pure and Applied Chemistry, IUPAC. So now the very important and the next topic that we are going to study is functional groups. Okay. So what basically are functional groups? The functional group is an atom or group of atom that is responsible for the feature of organic molecule. Yes, sometimes we have seen that in organic compound there must be a specific functional group that gives the characteristic feature to that organic compound. आई मीन दैट कि अगर किसी भी ऑर्गेनिक कंपाउंड के साथ कोई फंक्शनल ग्रुप लगा होगा तो उसकी प्रॉपर्टीज और उसकी जो केमिकल प्रॉपर्टीज होंगी और जो उसकी फिजिकल प्रॉपर्टीज होंगी उनको वो ऑल्टर कर देगा, यानी उनको एक स्पेसिफिक प्रॉपर्टी देगा. तो यहाँ लिखा हुआ है सेकंड पॉइंट में, ईच फंक्शनल ग्रुप हैज इट्स ओन डिस्टिंक्ट कैरेक्टरिस्टिक. As a result, a functional group is defined as an atom or a group of atoms whose existence in an organic compound gives distinctive qualities to that compound. Yes. What is functional group? Functional group is either a single atom or group of atom that attaches to the organic compound and gives the distinctive qualities to that compound. It means that whenever some of the organic compounds have a functional group along with them, so their properties are distinctive, characteristic properties. Like that, the functional group in alkyl halides, halides means halogens group 7 members. So whenever there is a halide attached to the alkyl group, I mean that when an organic compound is bonded together with any one of the atom of halogen, then it is known as alkyl halide functional group. While in alcohols, there is OH, hydroxyl group. You can see here that in OH we have a hydroxyl group. Okay, whenever you see OH group with any of the carbon compound, then you can see that this is an alcoholic functional group. The functional group governs an organic compound's fundamental chemistry, whereas the alkyl groups affect its physical properties. The polar hydroxyl group in alcohol, for example, improve the solubility. Yes, as we have discussed above that, all the functional groups can give a distinctive property to that of compound. So you can see here that the polar hydroxyl group, here you can see that the hydroxyl group in alcohol increases the solubility. It means that whenever any compound have hydroxyl group in its structure, then it is highly soluble in water, because the alcoholic group, the alcoholic functional group is increasing the solubility of that compound in the water. It means that it increases polarity, and you know that the like dissolve like theory states that the polar compounds can be only dissolved in polar solvents. So hydroxide is a hydroxyl group is a polar group, and this polar group increases the solubility or increases the polarity of that compound to become highly soluble in water. And sideways, we can say that the non-polar alkyl group, except hydroxyl, whenever any non-polar group is attached with that compound, it resists in the water. It will not dissolve in the polar solvent like water. It will dissolve in other non-polar solvents like benzene, petrol, kerosene oil, hexane, like that. Okay. Now, moving towards the next slide. Here is a chart where you can see the different functional groups based on their specific suffixes. So the first of all, you can see that we have alkane. As we have gone through in the class, that alkanes are those compounds in which the carbon-carbon contain single bond. So here you can see that there is a single bond between the two carbon atoms. Yes, class, there are. R is representing alkyl radical. In the class, when we are going through the topic of alkyl radical, so we symbolize the alkyl radical with the letter capital R. So where the R you can see where you can see R, it means that there is some alkyl radicals attached. For example, CH3, C2H5, like that. Some of the alkyl radicals are attached, and alkenes are what compounds that have single bond between carbon-carbon atoms, and the suffix that is used in that compound is alkane, like that methane, butane, hexane, heptane. Likewise, we have alkene. In alkene, you know that there is a double bond present between the carbon-carbon atom, and the suffix that is used is ene. And the examples are ethene, butene, hexene, and heptane. Now we have third one, alkynes. Alkynes means the carbon-carbon contain a triple bond. So here in this structure, you can see that the carbon-carbon is containing the triple bond, and the suffix that is used to represent the alkynes is "-ine". And the examples are ethyne, butane, hexane, and heptine. Now the next one, you can see that we have diene. Di means two and enes mean double bond. So some of the compounds in the class when we are giving the names to the organic compounds containing a double bond. So we have seen that some of the compounds have the two double bonds in their structure. And we have named them with the suffix diene, hexadiene, pentadiene, butadiene. So diene is also a functional group that contains the two double bonds in a chain structure or in a branch structure in a chain structure, and the suffix that is used to represent these compounds containing the two double bonds are diene. Examples are butadiene and hexadiene. In the next, we have alcohols. As I foretold you that alcohols are those compounds which contains hydroxyl group. So here you can see that with the carbon atom, we have hydroxyl group. That means we have alcohol. And alcohol is represented by the suffix ol, like that methanol, butanol, hexanol, heptanol. It means that in the end, we remove the E and place OL as a suffix, and OL is representing that these compounds contain alcoholic functional group. OL is representing alcoholic functional group. The next we have is ethers. What is ether? Whenever we have two carbon atoms and the two carbon atoms are joined together with the help of oxygen atom, like that we have carbon here and we have carbon here, and both the carbons are bonded to oxygen atom in between them, are known as a ether group. Okay, what is ether group? When the two carbon atoms are bonded together with the help of oxygen in between them, then this type of functional group is known as ether group, and the suffix that is used to represent the ether is oxy, like that ethoxy ethane or diethyl ether. So this is the ether functional group. The next one is aldehyde. What is aldehydic functional group? Whenever you can see a carbon and a carbon is attached with CHO group, it is collectively known as aldehyde. CHO. Whenever any carbon atom contains the CHO group, it represents that this functional group is aldehydic functional group, or these compounds are called as aldehydes. And the suffix that is used to represent the aldehydes is al, like that methanol, butanol, hexanol, and heptanol. Okay, the suffix that is used is al, methanol, butanol, hexanol, heptanol. Again, what is aldehyde? Whenever any carbon compound, any alkyl radical contains or bonded to CHO, that CHO is known as aldehydic functional group. Now moving toward the next, what is ketone? So here you can see that ketones. Ketone is a compound, a functional group, which we have two carbon atom, there is a carbon, there is a carbon. And these two carbons are bonded towards carbonyl carbon. CO is known as carbonyl carbon. CO, that there here CO, CO is known as carbonyl carbon. And whenever two carbon atoms are bonded to each other with the help of carbonyl carbon, then these are known as ketones. Remember that in ether, the two carbon atoms are bonded to oxygen. But in ketones, the two carbon atoms, the two chains are bonded to carbonyl carbon, not only single oxygen, but also the carbon. So it is collectively known as carbonyl carbon. Then ketones are represented with the suffix ketone, on, like that propanone, butanone, hexanone, pentanone. So the on is the suffix for representing the ketonic compounds. The next one is carboxylic acid. The carboxylic acid is what is the difference between carboxylic and aldehyde. There is a very single element difference, and some of the students also confuse in ether and ketone and aldehyde and carboxylic acid because of their resemblance in their structure. As you can see in aldehyde, we have gone through CHO, but in carboxylic acid, we have an additional oxygen. Here you can see that COOH. It means that whenever any carbon atom is bonded to COOH, it is representing that this is carboxylic acid. And whenever any compound containing carbon chain bonded with CHO, then CHO is aldehyde. ठीक है? And whenever we have COOH, it is known as carboxylic acid. And the suffix that is used to represent carboxylic acid is oic acid. For example, ethanoic acid, butanoic acid, propanoic acid, like that. Then ether and ester are sound alike, but their structure is different. You can see here that in ether, we have an oxygen atom that binds the two carbon atoms together. But in ether, you can see prominently that we have this carbon atom and this carbon atom, this carbon chain. And these two chains are bounded together with the COO. It means that when COO is present between the two carbon chains, then this compound is known as ester. When only single oxygen is present and bounded the two carbon chains, it is known as ether. And when the COO, two oxygen and one carbon, yani ki one carbonyl atom and one oxygen is bounded to the alkyl radical, then these are known as esters. And the suffix that is used to represent the ester compounds are OH, like benzoate, ethanoate, propanoate, like that. Then what is amides? Amides and amine. These also are sound alike, but there is a very minute difference, only a single element difference between them. What is amide? Whenever any compound contain carboxyl group and NH group. Whenever any compound contain carboxyl group and NH group, then this is known as amide. And what are amines? The NH2. Any carbon chain contains NH2 compound, then this is known as amine. Ethenamine, propinamine, okay? And the final we have nitriles. Nitriles, only the nitrogen containing compounds are called nitrile. So these are the functional group that alkane, alkene, alkynes, diene, alcohol, ethers, aldehydes, ketone, carboxylic, ester, amides, amines, and nitriles. These are some of the functional group that we have gone through in organic chemistry. Now the first functional group is alcoholic functional group. So as I foretold you, the functional group of alcohol is OH. You can see here that OH in any compound, any carbon chain is representing the alcoholic group. Their general formula is ROH. It means that any carbon contains OH group, where R is alkyl radical. Okay. Examples you can see there, methyl alcohol. It means that this is methyl radical and OH is present. It is named as methyl alcohol. This is ethyl C2H5 and OH is present. It means that this is compound is named as ethyl alcohol. Then N-propyl alcohol. Okay, got my point? All contains OH group in between them at the terminal, sorry. Now the second one is alcoholic. First one is alcoholic. The second one is ether linkage. As I told you, when the oxygen atom bounds the two carbon chains together, then this compound or this functional group is known as ether linkage. The general formula is ROR. When R and R are alkyl groups, and R and R may be same or different, there is no necessity that on the both side there will be methyl, on the both side there will be ethyl. There must be different alkyl radicals as well. You can see here dimethyl ether. Here's a methyl and here's a methyl, and in between methyl oxygen is bounding these two methyls, and therefore these now are named as dimethyl ether. Here two ethyl are bounded towards oxygen ether linkage, then this is known as diethyl ether. And here you can see methyl and here you can see ethyl, two different alkyl radicals bounded with ether linkage, so it is named as ethyl methyl ether. Okay, moving toward the third one, that is aldehydic functional group. So in this aldehydic functional group, you can see that aldehyde are the family consist of carbonyl functional group. Their general formula is RCHO. Yes, the aldehyde contains RCHO, where R stands for alkyl radicals. It means that R in the aldehyde is H. Okay, the R in case of aldehydic group is H, or any alkyl group. So in the example, you can see clearly here that this is H, this is R, and here you can see CHO is present. This CHO is collectively known as aldehyde functional group. So this compound is known as formaldehyde because it contains one hydrogen. Now here you can see that again we have CHO bounded with methyl. So this compound is known as acetaldehyde. Okay. The next one is ketonic group. And in ketonic group, you can see compounds containing the carbonyl carbon. This is carbonyl carbon. Two carbon compounds are bonded to carbonyl carbon are called ketones. And here the example, you can see that this is a carbon atom and this is a carbon atom. And these two carbon atoms or these two carbon alkyl radicals are bonded with carbonyl carbon. And therefore it is named as acetone or dimethyl ketone. And here you can see that one chain of carbon is here and one chain is here. And these two chains are again bounded with carbonyl carbon, therefore named as ethyl methyl ketone. Okay. Next slide. We have now functional group containing carbon, hydrogen, and nitrogen. The organic compounds containing carbon, hydrogen, and nitrogen as a functional group are called amines. As we have discussed that, what are amine functional group? The compounds containing the carbon, hydrogen, and nitrogen are called as amines. Their functional group is NH2. Whenever you can see any NH2 group attached with any of the carbon compound, carbon containing compound, either it is organic, and the general formula is RNH. For example, you can see here methyl is attached with amine, and this compound is known as methylamine. There is 2-methyl attaches with amine and H. You can see here dimethylamine. And in this we have 3-methyl group attached with a single nitrogen compound, and it is known as trimethylamine. And class, that's all for today. I hope so you can easily understand that what are functional groups and how many types of functional groups are present in your curriculum. And I can also tell you that these functional groups are very important and are crucial from the exam point of view. There must be a single question containing in the board exams that they give you some of the compounds along with the functional groups attached in them. And they ask you to identify the functional groups in the given compounds. So I hope so after this lecture, you're capable or you're eligible to the solve that type of questions in your exams. And if you have any queries and any further questions regarding this topic, you can ask me in your next class, inshallah. Hope you will all understand it properly. Goodbye. Allah Hafiz.